the product of a number and its reciprocal is, can you tell me what this is always equal to? So if I had the number 5 and I took the reciprocal of it, which would be 1 over 5, what happens when you multiply them together? It equals to 1. Let's try something else. Negative 2, what's the reciprocal of negative 2? Negative half. Let's multiply them together. What do you get? 1. So notice here that the number and its reciprocal, when I multiply it together, always equals to 1. Bless you. So let's do the same thing right now as exercise. Quickly, 5, 6. The reciprocal is? 6 over 5. Yes. How about 4? Okay, now I'm going to do something different. Instead of a number, I'm going to give you an expression. 2x.
1 over 2x.
Thanks, Vincent. 1 over 2x. And then how about the next one? X squared plus 1 then?
1 over x.
Just 1 over x squared plus 1. So the same idea works whether it's a number or an expression. The reciprocal just means take the flip or put 1 over it. Okay? So just like here where I said just as the reciprocal of a number which I call x is 1 over x. Now once again, you got to make sure that x doesn't equal to 0. Remember our learning in chapter 6 when we did the rational functions. Remember, you can't be dividing by 0. Similarly, the reciprocal of a function, which I will now call f of x, is really another function which I call 1 over f of x. And this is something that we must talk about later on. We have to now make sure that the f of x function does not equal 0. Okay, you guys take a look at example number 1. Okay, see if you can sketch out the graph of y equals to x while I graph or answer the phone. Okay, so I hope you're graphing this out now, and what I'm saying is let's show you how to graph out y equals to 1 over x, but before we do that, let's just do the simple y equals x first. So that's my original one, y equals x, and then my reciprocal graph will be 1 over x. Let me use these values here. Let's do negative 3, negative 2, negative 1. Let's do negative a half. Let's do negative 1/4. Let's do 0, 1/2, 1/4, 1, 2. That's a lot of points, but nonetheless, I think that'll help you out. Okay? Go ahead, please. Make the table values.
Wait, original is y equals x.
Yeah.
So it's the same thing.
That's right. Thanks. Same thing. And I know you're thinking, Mr. Lee, why are you making us write down so many? Please bear with me. I have a method to my madness. Okay? And if you can actually graph them out, I'd appreciate that too, to the best of your ability.
Can we just draw like a huge line sideways?
Yeah, that's what you should do. Draw a huge line sideways. Yeah. 45-degree line sideways. That's a good idea. Oh, that's not good. I need a ruler. Where's a ruler?
But can't you draw a straight line just with that?
Yeah, it is a straight line.
Oh.
I just need a ruler to do the straight line because.
Yeah, a line.
Oh, a line thingy. Right. Right. Who needs a ruler? Yeah, okay. Good. Okay, now let's do the funny one. What's the reciprocal look like? I'm going to ask you to use the same values, okay, please? Same values. Okay. And this time I'd like you to make the table values for the y. Let's make y, I'll use the color purple. What's the function then if x equals to negative 3? Y equals to 1 over x, so the y value is? Negative 1 over 3. Good. And I hope you know the pattern, so negative 1 over 2. What's the reciprocal of negative 1 though? Negative 1. Okay. What's the reciprocal of negative 1/2?
Negative 2.
Oh, negative 2. Good. Negative 1/4. Negative 4. Reciprocal of 0.
0.
Don't say 0. Undefined. Right. We don't know what this is. We'll come back to that in a second, but right now we don't know what it is.
Wait, isn't 0 over 0 just 0?
No. Don't know. But I'm asking you right now 1 over 0, not 0 over 0.
No, 0.
Yeah, so I'm saying 1 divided by 0. Reciprocaling 0 is 1 divided by 0. Okay? How about a half? What's the reciprocal of a half? Did you guys see what I just did there? That's kind of weird. I should have put that 1/4 first and then 1/2, didn't I? Yeah. How come no one told me this?
You didn't know that. You were waiting for you.
I wrote it already.
Well, you didn't tell me, Vincent. That's not nice. Well, okay, all right.
Does it really matter?
No, it doesn't, but
Okay.
it looks nice if it's in order, right? Sorry, dear friends. So what's the reciprocal of 1/4? I think that's just 4, then 2, then 1, and then this is just a half. Okay? I'm going to ask you to plot these points now. Okay? Don't worry about 0, undefined. We'll talk about that in a sec, but plot every single other point if you can. So -3, we'll do about 1/3. That would be down here. -2 is about 1/2, so right there. -1 is also -1. And then -1/2 is like -2. And then -1/4 is like, whoa, -4. And then let's not worry about 0 where it's undefined. We'll talk about that in a second. 1/4 is 4, yeah. 1/2 is 2, yeah. 1 is 1, yeah. 2 is a half, okay. Can you guys see what this graph looks like? This one I don't have a tool to use, so I can't use my line because it's not a line, so I'll just draw. Connect the dots, right. And I think up here we get something like this. Now, at 0, it's undefined, but we've gone through chapter 6. I taught you that extra stuff. What do you think we draw at 0? The asymptote. Thank you. That's that dotted line. Remember, Mean Girls, limit as x approach to infinity or whatnot. So here what I'm saying is, look, when I get closer and closer to 0, from the right-hand side, the graph shoots up way to the top. If I get closer and closer to 0, from the left side, the graph shoots way, way down. And I guess they never meet, so we draw this dotted line in between to show what we call an asymptote. Okay, and to be more specific, I'll say this is a vertical asymptote. And that's what you get here when you have an undefined thing. Okay, when it's undefined, you get what they call an asymptote. Okay. Now, I did teach you extra stuff from chapter 6, so there actually is one more asymptote here that I can show you. Do you know where that would be? Sideways, the horizontal one. Where is it? Vertical, sorry. Vertical asymptote. Yeah, so technically there's another asymptote here. Okay, this is the horizontal asymptote. Do you guys remember how to find the horizontal asymptote? Yeah, let me just quickly show you, and this is not part of the section, but you know, I did show you this earlier. Remember we do this, we take the limit as x approaches to infinity of the function 1 over x. So let's think about this. If I were to plug in a very, very big number for x into this reciprocal function, what's 1 divided by a very, very, very big number?
1.
Almost close to what?
0.
Tiny, tiny, tiny number like 0. So therefore, your horizontal asymptote, okay, is y equals to 0. Now, once again, this part here is just extra. In a regular class, they wouldn't touch it. But since most of you are taking calculus next year, why not show it to you now anyways? Okay. So, ladies and gentlemen, look what I've done here for you. In order for me to graph out the reciprocal graph, I went and graphed out what I call the original graph first, y equals x. They're connected. Now, I know that I've made a table of values, which is great, but I don't think you want to make a table of values forever and ever and ever. Do you?
Yes.
Okay, then you do that. Okay, and you take 4 hours for my test. But for those of you who don't, we have to try to look for some properties, some general properties that relate what I call the original graph to the reciprocal graph. Okay? And so to do this, I'm going to look at this example, but see if we can fill out this chart underneath. Okay? Now, can you tell me about the domain and range, first of all? Let's look at the domain of the original function y equals to x. Can someone tell me what that is? Domain, possible values of x for the original one. XER, right. All real numbers. Good. How about the range? YER. All real numbers. Okay. Let's keep going and filling out the first column first. Here's something new. It's called the end behavior when x is positive. AKA, since you guys know the limit notation, that means what's the limit as x approaches to infinity, okay? This just means positive. Positive, okay? So tell me, what is the end behavior? So what is the y value when x is really, really large? What's y? End behavior. Look at the graph, please. 0? No, I'm talking about the actual original function, y equals x. When x gets bigger, what happens to y? Bigger, bigger and bigger and bigger. We call that infinity, okay? So I'll say y approaches infinity. Okay. What about the end behavior when x gets close to negative infinity, or when x is negative? So this means negative. What happens to the y value here? Y approaches not 0. Careful. This is of the original function, okay? Way, 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 way down here. So negative infinity. Yes. We're talking about the y value, okay? That's why I said y approaches infinity. Y approaches infinity. And then what happens at actually x equal to 0? We got a problem. Undefined, or I'll say it's a vertical asymptote, okay? By the way, I'm showing all of you the calculus terms, okay? Vertical asymptote, okay? Or you can call it undefined, that's fine.
Isn't it just 0?
Oh, sorry. Yes, you got me mixed up. Sorry. At 0, the original function is still 0. Yes. Thank you. You got me confused. 0.
Because it's 0.
Why? What do you mean? Look at the graph. Vincent, you're looking at the wrong graph. I want the original graph. Original. Okay. Let's not worry about this last part, invariant points, yet. Okay, let's go to the reciprocal graph now. Okay, now, Vincent, it's your turn to answer the questions. Okay. Domain. What's the domain for the reciprocal function? Except for what?
0.
That's right. So it's all real numbers, yeah, but you have to make sure that x can't be 0. How about the range for the reciprocal function? Yeah, it's still all real numbers again, but also y cannot be 0, because that's where I have that horizontal asymptote. Now, this is interesting. What about the end behavior? When the reciprocal function is at infinity for x, what is its y value here? So what do we get? Closer and closer to 0. So I'll say here y approaches 0. And what about the end behavior when it's negative? Y approaches, yeah, 0 again. Ah. And now, Mr. Yu, can you give me your answer for the behavior at x equals to 0?
Undefined.
Yes, now it's undefined, or what I'll call it, a vertical asymptote. Okay? Now, before you turn the page, I want to introduce to you this term again called the invariant point. You've heard it in the absolute value section. I called it the breakpoint, but now they call it an invariant, meaning a point that's shared by both graphs. Can you tell me what point or points are on both of these graphs? Yeah, it's the intersection points, which are 1 and 1. And which is the other one? Yeah, -1, which is -1. Why are they invariant? Why does that occur on the original and the reciprocal? What's the reciprocal of 1? 1. Same thing, right? What's the reciprocal of -1? -1. Same thing. Okay. So here are some characteristics. Let's go to the next page. I'm going to try to summarize this in Mr. Lee speak, and then we're going to do some sketching. Okay. All right. Let's see if you can complete Mr. Lee speak here. Original. Okay, think original is like my y equals x, but now I'm trying to generalize this to all types of functions. Okay. Let's generalize. So when the original, which I call f of x, crosses the x-axis, meaning the y value is 0, what happens to the reciprocal function? It becomes positive. Let's think about this. Original from my previous example was y equals x. What happened when it was at the x-axis? That would be right here. What happened here when I took the reciprocal? What's the reciprocal of 0? No. Undefined. So the reciprocal is a vertical asymptote. Okay? Key step here. Okay? Key step. What I want you to understand is when the original has a y value of 0, at that same point, when you do the reciprocal, it becomes a asymptote. Okay, what's the next one? When the original has a y value of 1, okay? So if you look at my graph here, here's the y value of 1 right there now. Okay, what is the, let me answer this first, Katharina. What's the reciprocal equal to?
1 negative 1.
Well, when it's 1, it's just 1. Good. Edison also answered the answer for the next one. When it's negative 1, the reciprocal is negative 1. Katharina, yes? Okay, right now, when you are looking at this part, it's only going to tell you the vertical. Okay? To find out horizontal asymptotes, this is not really in Math 11, but as a way to figure out the horizontal asymptotes, you need to, like I showed you in that extra stuff, take the limit as x approach to infinity of the function. Okay? That was the extra stuff I showed you. Okay? All right, let's keep going back to regular Math 11 first. When the original has a small positive y value. Now, this is what I mean by small positive y value. Look with me. These are small positive y values, right? What happened to these points when I took the reciprocal? What did they become? Half? No. Small positive values, like this stuff here. Small positive values. Big, right, they became big. Remember, small, when I take the reciprocal of a small number, it becomes really big. That's right, Mr. Lee speak, small and big. Okay, so small positive y values, the reciprocal is a big positive y value. Is it hard? It is kind of confusing at first, you're right. We'll do more examples. Okay, so what happens when the original graph has a small negative y value? So let's think about this now. I'm going to go back to my picture. Small negative y values are these ones in green here. So that's these ones. What happened to those? They became kind of big negative values. Right. Small becomes big. So to answer part 6 and 7, when the original has a big positive y value, so what I'm saying here now, big positive y values are like way over here, which I'll circle in black. Big positive values. What happens to the reciprocal? They come way down here, they become small. And so yeah, big becomes small, big becomes small. That's right. Because when you take the reciprocal, everything is like the opposite. Okay? So let me show you how you can actually sketch some of these functions, okay, by using this summary that I have up here. So no more table of values. Oh, thank goodness, because it'll take forever us to do. Here's what you can do, okay? Let's do example 2a. Let's sketch this out. What I always like to do, dear friends, before sketching out the reciprocal is sketch out what I call the original function, okay? So this is like Mr. Lee speak, once again, the original function. So really it's just the denominator by itself. Okay, so can you sketch out y equals x minus 2? I hope you can do this without a calculator. What's the y-intercept for this one, dear friends? Come on. What happened to math 10? Negative 2, yeah, and then the slope is 1, so go 1 to the right, 1 up, 1 to the right, 1 up, right? And then here's your line. Now, once again, this is your original function. That's not really what I want in the end. Okay. Now I said, let's summarize the ideas from above. Okay. And let's use those ideas from above to help us sketch this out. Okay, you got it? Ideas from above? Don't fall asleep yet, kitty.
Awake.
Good. So what's my first step from my summary from above? I said when the original crosses the x-axis, what happens with the reciprocal graph? You get a, what do you get? Vertical asymptote. So tell me, point to me on your picture, where does this graph cross the x-axis?
2.
At 2. So what do I draw in at 2? At dotted line, right. So let's go ahead and draw in the dotted line, okay? So remember, first one, 0 becomes vertical asymptote.
Wait, Mr. Lee.
Yes, Mr. Yu.
What about horizontal asymptote?
Like I said, don't worry about the horizontal ones right now. I'll show you the horizontal one later, but technically, horizontal asymptotes are not part of the regular Math 11 curriculum, okay? Okay, what did I say for the next thing? The next thing I said was when the original has a y value of 1, okay, the reciprocal also has what? The reciprocal is also y value of 1. So where is that? Point to me where that is on your graph. What are the coordinates where y equals to 1? 0? What's the x-coordinate when y equals to 1? 3. So let me just tell you right now, this point is also a point on your reciprocal graph. Okay? When the y value is 1, the reciprocal's y value is also 1. Okay? And similarly for number 3, when y equals to -1, the reciprocal is also equal to -1. So what's my other big blue dot that I'm going to put on this picture? I think you messed them up. X comes first, right? 1, comma, -1, right here. Good. Okay. Those are what we call the invariant points because they are on both the original and the reciprocal graph. They don't change. Okay. All right. Now comes the fun stuff. Mr. Lee speak. When the original has small positive y values, what happens to the reciprocal of those y values? They become big. So, on your graph, with your finger, point to where you believe we have small positive y values. How about right here? Between the asymptote and that dot at 3, 1. So this area right here. Okay, so what happens to that area then? All those that were small become really big. So think about this point here. This would be like, I don't know, 1/10. What's the reciprocal 1/10? 10. It's like way up here, right? What about if I have a half? What would be the reciprocal of a half? 2. So right there. When I get closer and closer to 1, what about these points? They get closer and closer to 1. So these small values, watch me first, become large values like this. Okay? That's what I mean when I say small positives become big positives. Okay? And when I say this, I'm referring to the y values. Okay? Notice the x values stay the same. It's the y values that change. Okay? So that's number 4 here. Small y's become big y's when I do the reciprocal. Okay, don't be confused. Now, when the original has small negative y values, so tell me, point to where the original graph with your finger has small negative y values. Here? 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 Yeah, right here. So I'm talking about this region now, right here. And once again, if I were to make this, let's say, -1/10, the reciprocal of -1/10 is -10, way down here. Here's -1/2, so the reciprocal of -1/2 is 2. And so you get this. Okay. So once again for 5, I'll say small negative y become big negative y. Okay, almost done, dear friends. What's left? When original had the big positive y value, so big y's. Okay, where are my big y's? Big y values are way up here, right? So what happens to stuff that's really big? Right, so for example here, if I had, let's say this value is 3, the reciprocal of 3 is now 1/3, it comes down here. And then this is, sorry, that's 2, I guess, 2.5. 3 becomes a third. If I get further and further up, it gets further and further down, so you get this part of the graph. Okay, so big Y becomes small y. And last but not least, big negative Y becomes small negative y. So these are big negative y's, they become small. So how about, let's say this point was -2, it becomes a half, and so on and so forth. There you have it. But you can. So the answer is still the same. So for number B, I say, first of all, I'm going to ask you to sketch out this. So first, I'll say sketch out what I call the original. So what is the original? Y equals to x squared minus 4. Oh, look at this. Review from chapter 3 again. This is what type of lovely shape? U-shaped parabola. Nice. And if I asked you where are the x-intercepts? This is where Vincent said, can I factor? Yeah, you can factor. Yeah, you get 2 and -2. Awesome. So, yeah, and then the y value, the y-intercept is -4. That's great. So I hope you can draw a picture like this. Okay. And then now I'm going to ask you to use the same principles that I wrote down from above. And can you now sketch out the reciprocal of this graph for me? Let's see if you screwed up. What do I do first? I'm looking at the zeros, and I'm going to draw in my asymptotes. So I hope you did this. Okay, if you did this, you did not screw up. That's good. This is a good thing. Oh, okay, so fix it. Remember, I'm looking at where the x, or where the graph crosses the x-axis. So I'm looking for the x-intercepts. Wherever you see x-intercept, replace it with a vertical asymptote. Okay, the next step is what? Y values equal to 1, the reciprocal equals to 1. These are the invariant points. So where do we have y equals to 1? Well, y equals to 1 is like a line like horizontally here. So I think we actually have 2 of these. We have this one and this one. These are invariant points.
Wait, when they equal to, oh, okay.
When the y value, remember, I'm talking about the y value. One more time. Y value equals to 1. Okay?
X would be 1.
No. When the y value, okay, listen. When the y value of the original function, that's what we look at first, okay? Then the reciprocal y value is the same because the reciprocal of 1 is 1.
Gotcha.
What other value do we need besides y equals to 1? How about -1? So, where is y equal to -1 on my red picture here? How about this point? How about this point? So notice in this question, there are 4 invariant points. Okay? 4 points that occur both on the original and the reciprocal graph. Okay, now, I think these are the easier steps. The harder ones are the last ones here. Okay, so let's take a look. Listen carefully again. When the original has a small positive y value, the reciprocal has a big y value.
Yay!
So, these values that are right here, these small ones, what do they become? Big. So you get this part. Woohoo! Are there any other small y values in this picture?
Yeah.
Yeah, over here. So what happens to them? Woohoo! Big.
See, the thing going up, it can't cross the asymptote.
That's right. They can never cross the asymptotes. Okay, for those of you who are like, let's do it one more time, okay? Once again, wherever we have small positive y values, that would be this part here. Agreed? What happens to them? Small become big. What's a big y value? That's like 10, 1,000, whatever. So these points that used to be here get put up here. Here, 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 here. Okay? And same thing on the other side. Okay? All right. I'm on step number 5 when the original has small negative y values. The reciprocal is big negative y values. So where are my small negative y values? That's like these things here that I'm going to highlight in green right now. So what happens to them? They become big. So let me erase that highlighting. And I'll show you that those points become big. So small, big. Big negatives, right? The y value is negative. We're still keeping it negative. All right, so it's like you got these whiskers. Whiskers going up, whiskers going down. Okay, step 6 and 7, that's it. We get these done, we're done the picture. Step 6 says, when the original has a big positive y value, the reciprocal is a small positive y value. So now what I'm saying is, let's look at these things over here. Big y's, right? Big y's. What do they become? Small y's. So small, 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 small. So you have this. Small, 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 small. So you have this. Okay? And we're almost done. When the original has a big negative y value, the reciprocal is a small y value. So I would consider these like big y values. I know they're not that big, but whatever. What happens to them? They become small. Now watch, don't write this down first. Watch. Should I go like this? What's my problem if I did that?
Touch the arrow.
Yeah, it crossed the x-axis, bad news. Like, how do you make something that's negative positive? This is not absolute value, okay? Don't get mixed up with absolute value. Now, some of you might do this. And I'm like, that's not good either. Why? You should be able to at least find one particular point on this reciprocal graph. You know that this is 0, comma, negative 4. Agreed? So what's the reciprocal of negative 4? No, not positive 4. Reciprocal, not absolute value. Negative 1 over 4. So technically, you know that that particular vertex point got translated to this particular point here, and the coordinate should be 0, comma, negative 1 over 4. So at least draw your picture so that it gets to that point. Okay, but don't make it touch the x-axis either. Okay, and don't make it go over and above the x-axis.
Really, really close to the x-axis.
Yeah, you could. But still, show me that point you know as 0, comma, negative 1/4. Okay? And ladies and gentlemen, there is your reciprocal graph. Okay?
Wait, how come the keep going down?
Yes.
Shouldn't they go like that?
No.
Why?
You're saying, Edison, that these two going down should cross like this?
No, it should go like that.
Like an arc?
Like an arc? It is an arc. Isn't this an arc?
No, but shouldn't it go like that way all the way?
So, Edison, I think you're saying this, if I'm understanding you correctly. Wait.
No. Like it goes up.
Yeah. Watch. You're saying this. Like this.
Yeah.
Well, first of all, it can't cross the asymptotes. So,
Oh.
right? Okay?
I see.
Okay. Now, since you're in honors, you're like, hey, Mr. Lee, what's the horizontal asymptote? Let's figure that out. Okay? So, extra. What's the horizontal asymptote?
Y equals 4 for x.
Okay, how do we calculate horizontal asymptotes, first of all? So as a review, to find them, to find the HAs, I'm going to ask you to do this. Take the limit as x approaches to infinity of the function. Okay, so here we do that limit stuff again. So in this particular example, I want you to find the limit as x approaches to infinity of the function 1 over x squared minus 4. Okay. Now, I think I told you that one of the key things you can do, bless you, as a note over here is I'm going to say note the limit as x approaches to infinity of any function where x is in the denominator with a power of n. We know this equals to what lovely number?
0.
0, right. Okay. So how do we use that fact here to help us out? Well, if I want to show this to you formally, I'd say do the following. Take the limit as x approaches to 0. There's no x in the top, so that's fine. I'll leave it as 1. But I do want you to factor out the x squared in the bottom. Okay? And this is where it gets kind of weird, but let's just play along. What's x squared divided by x squared? 1. What's negative 4 divided by x squared? Yeah, just negative 4 over x squared. Okay? And you're thinking, well, Mr. Lee, why would we write like this? That's so stupid. Well, I'll show you why. Because now you have a lot of fractions, and with this fraction, with x in the denominator, what happens when I make x really big? Something big squared is even bigger, extra bigger, okay? 4 divided by extra bigger is really small, so small that it's about 0. So now what you have here is this is the same thing as the limit as x approaches to infinity of 1 over x squared, and this is like 1 minus 0, so that's just 1, right? So this is the same thing as 1 over x squared. Well, look at this, dear friends. We have another x squared, and really big squared becomes, big squared becomes really big, 1 over really, really big is, well, that's just 0. So what does that mean to you? So I say, therefore, the horizontal asymptote, okay, is y equals to 0. So if you want to make your graph complete, okay, and I know that if you're in regular 11, I would never teach you this limit stuff, but here we go. Do the actual horizontal asymptote also at 0. So you'll see that that graph, as when x gets really large, the y value gets closer and closer to 0, but never touches. Okay?
Is it always that x equals 0?
Not always, but most of the time. Okay? All right, dear friends. Page 3 is all yours, because you should be able to do all of this on your own now, because the ideas are the same. So I will stop talking, but I will give you a little hint first for part C. I want you to graph out this first, and then do the graph. This one is funky, by the way, so funky chicken, here we go. And then this one here, well, this is once again a parabola, so you'll have to graph out the parabola first. Hint, you might want to factor, and then from there figure out the rest. Okay? You've got a good 10 minutes right now. I hope that you can do all this. What I will do then is tonight I will do this myself, and I'll put page 3 online so that we can, or you can double check your work. I do expect you to do the homework even though I haven't finished this yet, because I think you can do it on your own. I will finish example number 4 next day, and next day will be your review period, because after that is your chapter 7 test. Okay? All right. Now, I asked you to graph out y equals x squared plus 1. Many of you did this. The y-intercept is 1, and you did a quick sketch. I like it. Okay? And then a lot of you said, okay, I'm going to use Mr. Lee speak and use those little properties. The first property was when it crosses the x-axis, we have a vertical asymptote. Where does it cross the x-axis? It doesn't. So that means there have no vertical asymptotes. Okay, so there's one funky thing. No vertical asymptotes for this one. Okay, step 2. Step 2 was the invariant points. When y equals to 1, the reciprocal y value is also 1. Where's that? There's only one place, right here. How about negative 1? Is there anything with negative 1? No. Huh? What? Right, so I'm almost out of time.
Oh my god, sorry. I thought it.
Okay. So anyways, are there any negative ones? No, so ignore that. Okay, move on to the next step. Next step says this. It says, when the original has small positive y values, small meaning between 0 and 1. Do you see any small positive y values? Anything over here? Nope. Okay, so there are no big y values.
Wait, small y values, can that also be 1, like we thought?
That's my invariant point.
Well, what about everything over the invariant point, like 1.00?
Well, that's what I would call big. Okay, maybe I should clarify this small and big stuff, okay? To be more specific, small means 0 less than y less than 1. So between 0 and 1. That's what I mean by small, okay? That's a good clarification. Yes, thank you very much for that. Small means like a number between 0 and 1, where big, of course, means bigger than 1. Okay? Does that help with the clarification?
So anything over the invariant point would be considered big.
That's what I would consider big. In Mr. Lee speak, it's big, yes. Okay. So let me just go back to your notes here then. So there's no small y values. All we have here are big positive y values. So what happens to these big positive y values? Well, let's take this one for instance. This seems to be like 1.5. What's the reciprocal of 1.5? 2 what? No, 1.5, this one. So that's 1.5, 3 over 2. What's the reciprocal of 3 over 2? 2 over 3, so I guess that's down here. This point here is 2. What's the reciprocal of 2? Half. Here we got 4. Becomes quarter. Here we got really, really big. It becomes really, really small. So I think what you see is you get something like this. Okay. And similarly for the other side, since this graph is symmetric on the y-axis, you get the same idea looking like this. Okay? Funky.
Wait, does it actually